Welcome to Section 4.1, Part 3. This is the 36th session of the ISACA CISA exam prep series. This part picks up where the last one left off. In this session, we'll cover computer hardware and the devices behind it. We'll work through several questions. What's inside a computer and what types exist? What back-end devices run an enterprise? What risks come with portable storage and wireless? And how do you maintain and review hardware? Why does this matter beyond the exam? Because hardware is where the abstract finally becomes physical. Picture a design studio called NorthForge. One unencrypted drive walks out in someone's pocket and confidential work is gone. A server overheats because maintenance was skipped and a deadline slips. Knowing the hardware lets you see those risks before they bite. So what's inside a computer? At its heart is the processor. It might be a single chip, several chips, or many cores on one chip. Inside it sits the logic unit, the control unit, and a small internal memory. Around it are the other parts: the board, working memory, permanent storage, power, and cooling. Storage comes in two flavors worth contrasting. A spinning hard disk has moving parts. A solid-state drive uses flash memory, so it's faster and more durable. Many machines also add a graphics processor. It was built for graphics, but now powers heavy calculations for machine learning and artificial intelligence. And input-output parts let you feed in and read out data. A keyboard is input only. A printer is output only. A touchscreen does both. So what types of computers are there? They range from the giant to the tiny. Supercomputers are massive machines built for the heaviest calculations. Mainframes serve thousands of users with high reliability. High-end servers rival mainframes in power, but cost far less. Personal computers serve one user, though they're usually networked. Thin clients keep almost nothing local, pushing the work to a server. Laptops are portable, which also makes them easy to steal. And small-form devices, single-board computers, and handhelds round out the bottom. They pack real computing into a tiny package. So what devices run an enterprise behind the scenes? A whole family of servers, each with a role. Print servers consolidate printing across the organization. File servers give central access to files and programs. Application servers run business logic for client machines. Web servers deliver pages to customers and staff. Database servers store the data the others turn into information. A data loss prevention gateway inspects traffic to stop sensitive data leaving. And appliances are specialized boxes, like firewalls or load balancers that do one job fast. Proxy servers deserve a closer look. A forward proxy sits in front of users, fetching the internet on their behalf. A reverse proxy sits in front of a server, balancing load and shielding it. And an open proxy is reachable by anyone, which is why organizations avoid them. One more trend matters here. The Internet of Things keeps multiplying connected items, from cameras to medical gear. That brings innovation, but also data leakage and privacy risk. So what risks come with portable storage? Those small drives that plug into a port are everywhere. They're convenient, but they carry real danger. They can ferry malware from one machine to another. They make data theft a crime of opportunity at any unlocked desk. They're easy to lose, exposing whatever sits on them. Pulled out improperly, they can corrupt their own data. And their size and capacity make a confidentiality breach easy. So how do you control them? Encrypt them so a lost drive is useless without the key. Use software to manage ports, allowing only approved devices. Educate security staff, since these drives are easy to conceal. Lock idle desktops, and scan every attached drive for malware. So what about wireless technologies? Three show up most often. Wi-Fi delivers high-speed internet over radio waves. Bluetooth links nearby devices over short distances. And radio frequency identification tags objects so readers can track them. Wireless wins on three fronts. Convenience, since there are no cables. Mobility, since devices roam freely. And scalability, since you can add many devices easily. So how do you maintain hardware? Equipment has to be cleaned and serviced on a schedule. Match that schedule to the vendor's specifications. The program should record the servicing details: the service company, the schedule, the costs, and the history. And management should explain any deviation from vendor guidance. Several reports keep hardware honest. Availability reports show when systems were up, exposing excessive downtime. Hardware error reports flag failures to fix. Asset management reports inventory the connected equipment. And utilization reports show how heavily machines are used, helping you forecast needs. So how should an auditor review hardware? Check several areas in turn. Is the acquisition plan aligned with business needs and the architecture? Do hardware purchases follow that plan with cost-benefit analysis? Has each asset been tagged and given an owner? Is capacity monitored continuously against real data? Is preventative maintenance done off-peak on the vendor's schedule? Is availability enough to meet the workload? And are malfunctions and reruns being reviewed? So let's bring it together. A computer is a processor surrounded by memory, storage, and input-output. Machines range from supercomputers to handhelds, served by back-end devices. Portable storage and wireless add convenience, but also real risk to control. And hardware needs scheduled maintenance, monitoring reports, and regular review. Master these three parts, and you understand the full stack technology operations rest on. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.